Good evening and welcome to all. As part of our Tech Tuesdays, it's my pleasure to invite Rahul Bhalla, who for the session today. Rahul is the co-founder and CEO at Zenetics. It's a firm that he and his batchmates formed about in 2014. Rahul is a graduate of IIT, and prior to founding Zenetics, he's built some about 3, 4 KPO businesses. Zenetics, coming to the focus on Zenetics, Zenetics is a company which provides IoT-based automation solutions targeted at delivering energy efficiency, occupant comfort, and improved asset management. Now, this is a subject that we did pick up in brief a few weeks back, and I personally believe this is the technology to look at in the coming years, or starting now, not to be waiting for. And hence, we kind of invited Rahul here to share with his experiences, as he has done a lot of implementations for his various clients. And I think we look forward to hearing from you, Rahul, on how your solutions or this new piece of technology can help us in our day-to-day works.
Sure.
Please.
Yeah, thank you, Shailendra, for the welcome. Good evening, everyone. It's my pleasure to be here today. And I would sort of love to talk about, the topic that's circulated, right, which is how, IoT is creating smart buildings, or how IoT is enabling smart buildings. I think there is a lot of buzz about IoT. The question is that how, IoT can sort of change the traditional building technologies, obviously bringing in a lot more value. So let's talk about that. I will take about 25 to 30 minutes to run through the session. I'll present some slides. Please keep dropping questions in the Q&A, as Jatin's mentioned. And Shailendra, you may pick up some questions during the session as they may be relevant for the course of conversation, or towards the end as well, where we can reserve for about 15 minutes for Q&A, right? So let's start that. Let me just quickly share my screen. Okay, I hope you are able to see the screen, right? All right, so the topic, as I mentioned, is how IoT is enabling smart buildings. I'm one of the co-founders at Zenetics and also the CEO. Let's start first with understanding. All of us obviously have heard of the term smart buildings. I've heard of terms IoT, but in a simplistic terms, it's a building. Smart building is a building which uses automation, data to control the overall operations. This may mean different parts of the building, controlling HVAC, lighting systems, UPS systems, security, access control. So there are multiple use cases which are being driven by specialized IoT organizations who may focus in different areas. But what you really, at the end of it is sort of see is there are obviously use cases like smart energy management, asset management, smart lighting. We hear them all the times. So these are, anything which is sort of controlled through data and automation is a smart buildings. And at the heart of it, it uses, three things. One is it uses a lot of sensors for feedback, for collecting data. It uses actuators for automation and controls. And then there are gateways which are connecting these sensors and actuators to a centralized cloud platform where you can sort of see all these buildings, manage them better, and so on. So that's what the concept of a smart building is. Moving on, there is a significant, need gap, basically there is a requirement in buildings for such automation and IoT. I will slice and dice the landscape into two parts. Let's first look at, there are light commercial buildings, which are, let's say, less than 100,000 square feet. And there are large commercial buildings, which would be, let's say, greater than 100,000 square feet. And this sort of differentiation is done globally, even in markets like US. So in the smaller size buildings, typically, the BMS, the building management system penetration is virtually non-existent, because the BMS systems were developed for large buildings, that they do not make any sort of economic sense in the smaller spaces. In the large buildings, so therefore, there is, cost economics being a challenge, but you still need, in that building or a portfolio building, you still need energy and asset management. And that's where IoT is coming in, because IoT is lightweight technology. It is hardware light, software intelligent technology, which makes economic sense to be deployed in this white space. And then there are large commercial buildings, which have either, they have a BMS, or they are again without a BMS, or there are some which have a partial BMS implementation. For example, it controls the high side, or it controls the low side, or it controls only the access control system, security systems, does not control HVAC. So there are different types of implementations which are there. Now, if you look at the traditional building management system space, BMS systems were classical automation systems. They did a great job for decades, and I think, but at the same time, they brought in some challenges. One, they tend to be expensive, which is why especially in the Indian context, the penetration is extremely low. It is a technology which is hard to sort of maintain. A lot of times we hear from customers that the BMS stops working after a year or 2 years, because it's a technology that's developed for the West, and India is a very, very different environment. There is a lot more dust in the environment. There is a lot more power fluctuations. A lot of challenges sort of come up in the Indian environment, and the new age challenges that are coming up. Did somebody, were you saying something, Surendra? I heard something. All right. So, and the new age, requirements that are coming up as that these are non-connected systems. While I think some of the OEMs are trying to connect some of the BMS systems over cloud and etc., but that's not traditionally how they are built. So there is lack of predictive maintenance analysis, which is the need of the hour. So these are the things. And plus, I think, a lot of portfolio, people who manage a portfolio of buildings, they have building management systems from different players. And, none of these players tend to have an approach where they can integrate everything. So the requirements in this space are, you need a OEM agnostic platform, which means that whether you have a Honeywell system or a Schneider system or a chiller from a Daikin or a Voltas, IoT should enable a consistent platform approach where they can connect to different types of systems. There is a need for cost efficient and faster ROI technology. And then with a focus on, artificial intelligence powered predictive maintenance and so on, right? So this is how, the whole landscape is currently there. The challenges, as we understand, there are multiple challenges, I'm sure you guys also face some, which are, a lot of them are related to energy, because energy is a big measure. And, today we will talk a lot more about energy management use cases, because that's where we have a lot of experience in, and I can talk about how, different IoT is being used in different places in the energy context. So there are issues around equipment is operating when it's not required. What is the optimum time to switch on a chiller or other equipment or lighting systems? There are suboptimal comfort compliances, which are, people feeling hot or cold in certain areas. There are more frequent asset breakdowns happening. There are poor power factor issues, efficiency related issues. So there are a number of challenges that do come up in buildings. And when we come to IoT enabled automation, this is how a classical architecture looks like. So you have your equipment on one side, which is, your HVAC systems, chiller based systems or air cooled chillers, or, a lot of VRF systems are gaining traction these days. Or these could even be, high wall splits, ducted package units, different types of air conditioning systems could be there, lighting, exhaust fans, anything which is, there in the building. And what IoT does is that it allows connecting of this equipment over to a, common platform through different interventions. So IoT also allows that if you have a BMS, you don't need to sort of, throw away that BMS. IoT allows to sort of connect with this BMS over standard protocol like BACnet over IP. And then it has its own sort of sensors and actuators which you can use to connect the equipment. And these could be wireless sensors. A lot of them are these days wireless sensors: temperature, humidity, air quality, CO2, UPS, battery voltage. Different kind of sensors are required. And then there are actuators which can control air conditioning, chilled water valves, VFDs, air handling units, secondary pumps, primary pumps. All of them can be controlled through these actuators using different intelligent logics. And both these sensors, actuators, and the connections to the BMS happens through typical gateways or controllers at every location. So this communication may happen over wired or wireless protocols, and then these gateways talk over to a cloud platform over internet. So this internet could also be different types of, it can take Ethernet, it can take Wi-Fi, it can take a GSM connection if a customer has a concern that, particularly, let's say banks or their BPOs in India, they would never let you get onto their network, right? So therefore, GSM technology, SIM card-based technology can simply allow these connections. And then, on the cloud, you have, your multiple buildings onto a common platform, and you can access dashboards and everything, right? So that's how a typical IoT architecture looks like. What are the benefits? I think, energy management is a clear benefit. So you achieve a lot of energy savings through automation, intelligent automation. There is now this concept emerging, which we see quite a lot in the market. Shailendra, you have a question?
Oh, please go ahead. I think someone else has raised a hand, and I would like to tell all that if you can please put your query on the Q&A, we'll try to answer that. Yeah, please go ahead.
Sure. So one of the things that is emerging in the market is the whole concept of remote asset monitoring and controls, right? So remote asset management with, COVID striking us, I think there is a need for remote asset management. So anybody who has a lot of, distributed offices, locations, whether these are back offices, large office buildings, smaller branches, all of that, organizations are trying to get everything, being monitored centrally. So I'll give you examples, what can be done. Example could be, your power monitoring can be done centrally. UPS systems are critical systems. If they are, if you want to monitor even the battery voltage at a battery level, that can be done. Server rack temperature can be monitored. And these are sort of wireless plug and play sensors. You just deploy on the top of server racks, and they can start transmitting the data. Earthing voltage is a problem at a lot of locations. That can be monitored. So that's on the monitoring side, that how do you connect, get the data, and then automatically generate alarms if something goes wrong. Also, a lot of organizations are using this IoT technology to connect all of their locations onto a common platform from a remote asset management standpoint, so that the dependency on visits, etc., can be reduced, because visits have become a very challenging part of these times. So how can you do a lot more predictive? Temperature, humidity compliance. A lot of organizations, send people to take temperature readings from time to time for comfort, fully automated. These are plug and play sensors, which will never disrupt your aesthetics. And they work, the new age technology in wireless sensors is what you call as mesh. So, the traditional form of wireless has been Wi-Fi. In Wi-Fi, what happens is that you connect all the sensors onto a single gateway. But in mesh, what happens is that, one node speaks to the nearest node. So it works like a beautiful mesh. And then the one node which is closest to the gateway will talk to the gateway, and then the gateway talks to the cloud, right? So these are all the benefits. You can do fault detection and diagnosis or predictive maintenance using data. You get centralized dashboards. You can get ticketing workflows which can push notifications. And finally, you will require seamless integrations, because everything is over the web. The systems can expose APIs to your existing ERP systems or other systems, so that there is a seamless integration. So these are typically, benefits that you see using IoT-enabled automation. How IoT is disrupting the building technologies, right? So I think, as I briefly mentioned, there is, it's a hardware light technology, software intelligent solution. So when I say hardware light compared to a traditional BMS, the wiring is probably 30 to 40%, because it's a very distributed architecture. So you are not wiring all the DDCs onto a common BMS room. The sensors are communicating wirelessly, the actuators are communicating wirelessly, and then they are communicating to the nearest gateway, which independently talks to the cloud. You don't need to network all the gateways. So there is a lot less wiring in a brownfield environment, and the cost points are also typically 60% of a typical BMS cost, or even sometimes lesser. There is a lot more wireless technology, which makes it very easy to deploy. OEM and machine agnostic approach is something I touched briefly, that our customers want a common platform. They don't want to be married to one OEM. And if they have multiple systems, how do they integrate onto one common platform? The IoT systems tend to be a lot more plug and play for easy deployment. They are very cost effective. ROIs are 12 months, 14 months, as opposed to a traditional 3 to 5 year ROIs seen in the industry for other types of interventions. So I think that makes it, very, very viable technology, and it is getting center stage attention. And, a lot of organizations are using it, and it's really creating a disruption. This is an important one, where, you see that how organizations are moving towards a platform centric approach. So, you imagine your portfolio, in terms of buildings. There are, existing buildings, and there are three categories that I initially spoke about, properties with full BMS implementation, with partial, and with no BMS implementation. So what needs to be done, using IoT is that, you leverage the existing BMS system. So you connect with the BMS here. In this case, you connect with the BMS in the second case, but you also fill in the gaps. So if, let's say, BMS is partly covering this building, only high side, then you cover the low side, you install, chilled water valve actuators, VFDs, etc. All of them are sort of controlled by the system. And whatever is existing BMS, you connect to the BMS to bring everything to a standard platform. And then where BMS says there is no BMS, you deploy IoT-based automation, so that now you have everything, all the buildings onto a common platform, which provides you consistent visibility. So if you have multiple buildings, you want to sort of say that, look, I want to monitor the reception area temperature of all my buildings onto a common platform, possible. I want to look at energy consumption per square feet area across all my buildings, possible on the platform, right? How are you trending with respect? So everything you can done in a very consistent way. And of course, the additional benefits are energy savings, compliance management from a guest comfort, occupant comfort standpoint, and asset management, that how do you do predictive and preventive asset maintenance. And then once you start new buildings, you again have an option, whether you take a IoT based BMS or you take another standard Honeywell, Schneider, Siemens, JCI BMS, and then you sort of irrespective, you are again able to connect the same platform. And this has an access control. The platforms typically have access control. The corporate business owners can see what's happening. The project leaders can see all their buildings. The regional guys see only the buildings in their region, and the site engineers see only that particular building. So complete access control is possible. I'll just take an example of this in action. So we actually worked with a customer which owns 26 hotel properties in the country, which are very, very large properties. I mean, a combination of small properties like Holiday Inn Express to a very large property like a Sheraton Hyderabad or a Hyatt Regency Pune. So this particular owner runs these property. I mean, essentially they own for these brands. And the problem statement was that how do you connect such a diverse infrastructure over to a common platform, which we successfully did using IoT. And 26 properties are on common platform where they can see examples. I said, lobby area temperatures, guest area temperature, guest room temperatures, back of the house temperatures, humidity, CO2 levels, PM 2.5 levels from an overall comfort standpoint. Then you look at from an energy standpoint, you benchmark on different bases. And then, there is asset management. So what are the areas where the VFDs are, let's say, running in a bypass mode? Where is the issue of, condenser side? Delta T is very less on a condenser pump. So multiple issues are identified using the operation, and at the back end, the automation is always functioning, right? So, the systems are automated, and, the IoT allowed us to sort of, connect to 4 properties which already had a BMS. So the example I was mentioning, that you leverage what you have, and then you sort of, fill in the gap with, additional technology which is there to bring all the properties onto a common platform.
Rahul, I will interject there just to
Sure.
kind of, break the monotony.
Sure.
Question there. So data being available at a particular property or a particular office location is one thing. In any of these cases, were you kind of creating a central dashboard for, let's say, the overall chief engineer or the operations head, who could look at all the data and possibly compare the performance data across the different facilities?
Correct. So this is an example right on this slide. This was done. So 26 properties in 12 different cities were connected onto a common platform. So, and the way the governance was set up was that the site chief engineer was able to see his own property in terms of energy, comfort, and asset management. And then they had a corporate person who was looking at all the properties on a central level. And the platforms or dashboards are completely customizable. So somebody may want to see energy expense per person, energy expense per occupant, per square feet area, whatever benchmarking is, you want to sort of do, that can be done. And more importantly, because the technology allows you to run complex algorithms on the cloud, it can done analysis to identify problems with compressors, motors, all of them, and create tickets in the system. So the governance is set up in a way that, the site engineer solves those tickets, and then the corporate guy basically is ensuring that the tickets are being solved at all sites.
Okay. Now, another one would be that, you can get all the data. And I think one of the biggest challenges that even BMS has been that most of the BMS implementations, at least that I have seen, you can see the data on a screen after that. So is there something beyond the data capture, the dashboards that you are doing?
Right. So I think, data capture monitoring is, one aspect which allows you to sort of stay on top of, everything from an operational standpoint. But I think the question, is that how do you deliver energy savings, or how do you deliver quantifiable benefits, right? That's where automation comes in. And automation is something IoT, we have been doing for a long time now. And as I said, the automation can be done from a perspective that you can control a simple high wall split to a cassette, to a package unit, to a VRF, to a chiller based systems. All types of air conditioning systems can be controlled using different types of actuators. So full automation is done. Lighting systems can be automatically controlled. Exhaust fans can be controlled, and that delivers, VFDs can be deployed and controlled, and that delivers tangible 10 to 20% energy savings, which the CFOs like, and therefore they can able to sort of approve the projects. And the administration leaders, facilities leader are able to add a lot of value to the organization sort of using this IoT technology. So that's one side which is beyond data. The second side is that a lot of machine learning and algorithms are used to identify anomalous operations. Set temperatures being so low, wall operations walls not working well, walls are stuck. All of these things can be identified through data. And if the tickets are created in the system, then they become actionable. So I think, we don't expect that, providers, throw a lot of data and graphs at the customers, and then the customers start, figuring out what to do with the data, because, there is no time to do it. And therefore the system should be such that it's a combination of monitoring, dashboards, which helps you understand what's going on, automation, which delivers savings, and then, anomaly detection and creation of tickets so that actions can be taken in real time.
Okay.
And that's all possible through IoT.
Sure, thanks. Now, a couple of questions have started coming up.
Sure.
Now, one of them, of course, is on cost, as to how expensive that can be. Now, would you have some case studies which you would like to pick up before we get on to the questions, or?
Yeah, no, absolutely. So this is one case study, and I'll take one more case study.
Yeah, so
to
maybe you
actually
can pick up the next case study and then we can come back to the questions. Yeah.
correct. So this is the case study of a larger buildings environment, and then there is a case study on a very smaller environment, which is a quick service restaurant, which is 2,000 3,000 square feet. So this is something that we did for one of the leading QSR chain in India. They have about 1,300 outlets, about 120 crore plus annual power spend. 250 cities in India they're present. So we basically used again IoT to connect their ACs, lighting systems, exhaust fans, glow signs, all to a common platform and fully automated the operation. So ACs come on at a particular time, switches off. Because what tends to happen is that the ground person who is responsible for switching on and switching off, he is not paying for the electricity bill out of his pocket, right? And by the time the leaders actually get to the office, to sort of understand, the damage is already done. The cleaning guy comes in the morning and they'll turn on everything, right? So how do you stop that human behavior, or how do you manage that behavior is predominantly through automation. So this is what we did for these guys. So today we have 900 restaurants of this QSR chain on our platform, and we've been able to reduce their spend by about 9% on a 120 crore spend, and 30% improvement in food safety compliance, because food is important for them. So we monitor in real time the temperatures in their chillers, freezers. There is improved visibility for corporate governance, right? So you see that IoT is scalable. It can start from a 2,000, and in fact, we've done literally 300 square feet outlets also. Pharmacy, milk booths in the past as well. It can start as low as that, and it can go to a 500,000 million square feet building, depending upon what the requirements are. And the cost points could vary from as low as a 30,000 rupee hardware to a 50-60 lakh rupees of hardware, depending upon the scale. But I think the important thing is, what is the ROI, right? So because the price points are going to be in relation to the size of infrastructure, but we have consistently delivered 12 to 14 months ROI flat, no questions asked, and which is why we saw that IoT adoption happening.
Yeah. So coming back, I think one of the participants has asked a question, and the perception is that there is a huge capex investment required, which may give returns at a later date, but the challenge is coming up with that upfront investment. And as I said, the perception tends to be that the capex investment is very high. Now,
right.
What is your take on that in terms of how expensive can it be to just roll out the system before? And rightly, I think any benefits will possibly start coming up only after a 3-6 month period, depending on what kind of environment you're working on.
Correct. Yeah. So I think there are two parts to the question. One is that how expensive it is. Second is engagement model, that a lot of people can come. Organizations are cash constrained at the moment because of the COVID situation and so on. So I think on the first point, I think there is certainly a perception in the market, which is that these systems are very expensive, and that perception is predominantly created by a BMS, because BMS systems are expensive. So I think if you benchmark the cost of IoT solution with respect to a BMS, we have done various benchmarks. So let's say if a BMS system, a typical BMS from a Schneider, Honeywell, Siemens, JCI, these are the four big players, cost about 100. Then an IoT equivalent system with all the same bells and whistles as a BMS costs anywhere in the 60 to 70 range, because you have reduced the cost of wiring, commissioning costs, all of that, and it's a lot more wireless, easy to deploy, right? Having said that, BMS, anybody who's familiar with the BMS industry, they see the consultants making these IO summaries and saying, look, I need a BMS. Nobody challenges that IO summary. There are lots of bells and whistles in IO, BMS, which you get, which stops working after 6 months. Some of those sensors are always forgotten. So there is a value engineered IoT solution, which is focused on energy management, compliance management, and asset management, because these are the really three things that you need in a building, right? From these perspectives. And that value engineered solution, which is basically targeted at these things and does not take into account bells and whistles of a BMS, that costs about 40, right? So now you have two options. Instead of 100, you pay 60 for a like-to-like, but a IoT technology, and a value engineered solution, you pay 40, right? So a lot of organizations who, said we didn't have 100, but now can pick 40 because that saves you energy. And that 40 will give you a 12 to 14 month ROI,
Sure.
right? So that's the first aspect. The second aspect is somebody doesn't have capex to incur right now. So I think, there are engagement models which are out prevalent in the industry. Somebody can give you an OpEx model. For example, we do OpEx models with customers because we have a line of debt with the bank, which finances this. So you become cash flow positive. So you pay me X, I'll give you savings of 2X right from day one.
Sure. Okay. The next question would be that, are you able to operate devices through a central control room? And
Yeah. So the platform allows you to operate from a central control room, or actually, the control room concept is also gone with IoT, because there used to be these NOCs, where there are a lot of computers, and, people viewing those screens, right? Or even BMS rooms having, those sophisticated computers with a high grade, memory and all of those things costing 2-3 lakh rupees. So IoT takes all of that away. Now your control room is your phone or a laptop, right? And you can control centrally. You can slice and dice the controls in any way, whichever you want. You want to keep the control at a site level, you give access to the site level. You say that, for example, in a quick service restaurant scenario, the customer didn't want to give the control to those site guys. They said, this is have fixed timing operation. You don't need anything else. Therefore, the control resides with the central guys or the regional guys. So it's a completely flexible technology.
Okay. And another question on what is the timeline that people should look for if they are to implement a solution like that? And I think maybe you should answer that in 2 steps. One is, if I am having an office space of 100,000 or plus square feet, and the other situation could be where we possibly have something like a banking and insurance sector where we
smaller outlets are there.
Smaller outlets, maybe 5,000-10,000 square feet, but multiples of them and spread across.
Correct. So I think, again, comparing, the benchmark is the BMS, right? So the benchmark in a BMS is that it takes anywhere from 3 to 6 to 9 months or never ending commissioning. In some cases, you were 80% is commissioned and the 20% never got commissioned. We've heard all of those, all of us in our lives. So IoT technology is, again, sort of, even in the deployment standpoint, it's very, very user friendly. So the way, for example, we deploy is that if I get 100 outlets, and that's how we get from in the smaller environments, customer will give us 100 or 50 stores at one go. We would typically execute them anywhere from, from getting the purchase order, anywhere from 30 days to 60 days. That scale also, right? For a large building, if I'm looking at one building, I would say 30 to 45 days is the typical time for execution, right? Again, from the purchase order date, right? So you are curtailing down the time of 6 months now to about 30 to 45 days, because this is a lot more wireless, easy to deploy. And, you have apps to connect to the site. For example, our central team will connect to a site over a VPN connectivity for security, but they can still see what is happening. The electricians have mobile apps to test what have they deployed. So it's a complete retake at the technology that used to be existent before.
Sure. And I think one more question, which maybe I'll answer. There's a question which says, when you state you get savings from day one, what is the expected percentage and how is this achieved? So, my friend, I think the expected percentage would actually depend on what is your operating environment and what is, what are the equipment that you control. If you are controlling the high side, so let's say you're controlling your air conditioning, whether it is split or ductable or units, or even if you're controlling the chillers, of course, the reductions that you can expect will be much higher than in an environment where you are only controlling your internal office lighting and maybe at most the AHU operations. So the savings are purely dependent on your own operating environment.
Right. I will just add, if I can just add to that, Shailendra. So I think, yes, you're absolutely right that what is in your scope. And obviously, if it's a larger, you have the high side in your control, you're going to get much more savings as compared to when you have only low side with your control. But I think, some benchmarks, which we have seen. And again, that's where IoT technology is flexible. So if you are in an environment where you just own a couple of floors in a building and you don't have control over high side, then what is in your scope? AHUs. Maybe you can deploy some VFDs on AHUs. You can control lighting. You can manage, exhaust fans, all of those things. And because your bill is lower, the percentage is roughly, again, comes to the 8, 10. So we have seen a range of 8 to about 20%. In a high side environment, obviously that 20% number looks much bigger because the base is very large. But again, it's adaptable. You can do a full building. You can do only high side if you're a developer, or you can do only the low side if you're a tenant.
Sure. So maybe a couple of more questions, but I think let's move on with your presentation and you can come back.
Yeah. Yeah. So I think, I think I'll just make 1 or 2 points because we covered a lot. So I think we already spoken about a use case, right? What is IoT doing in buildings? Energy management through centralized management, monitoring and intelligent controls. We spoke about it, right? So you see, this is a typical data which also tells you validate what's IoT doing. So, we typically, deploy systems, we don't control anything and then show the benefit to the customer that, look, you are turning on the AC at this time typically, which is the blue line. And with my automation, now it is turning at the right time. So you are saving this much energy. Similarly, you're switching off earlier. Lighting operation also, if you're staggering, I can stagger it better. So, and it's all sort of data driven where you see measurable benefits. The second is fault detection and diagnosis, right? How do you do that? Lots of ACs which have compressors, traditional compressors. Typically, a compressor needs to have this cyclical behavior, duty cycles. Bad compressor, temperature is being maintained, but it's always on, consumes a lot more energy, will eventually break down, easily identifiable problems. Safety side, when you build up a building, you essentially ensure that the loads are balanced on all 3 phases. Over time, people take out one load, put it on from R to Y phase, Y to B phase, and it creates a load unbalance over time, right? So there is a need to flag that. So this is something you see different loads on different phases, red, white, blue. And before intervention, we told the customer that look, this is a red has a lot more load. You need to move out some load to yellow, which they did. And you see the intervention. So prevents fire safety hazards. Temperature, humidity compliance, you can see, where are you in terms of temperature and humidity. All of them can be done. CO2 levels. A lot of customers are nowadays asking for PM 2.5, VOC measurement. In the COVID environment, are you maintaining the right temperature and the humidity? Because there have been studies which are indicating that for the viruses to sort of not grow, you need to have a certain, percentage humidity and right. And I think I'll just take, 1, 2, 3 more minutes. I think, there are key learnings that we had, while we saw adoption from a customer standpoint. Why? First of all, I think if somebody says, I want to adopt IoT or I want to go for a smart building, the first question should be, why do you need it, right? What is that you want to achieve out of it? That objective should be super clear. You want to achieve energy efficiency. You want to improve compliance, which could be one mandate, or you want to reduce equipment breakdowns, or a combination of 2 or 3 or all 3. But your primary objective should be clear, right? Second, the technology should have a measurable benefit and use case, because a lot of times, especially in these times, the CFOs are going to ask this question: what is the benefit I get? Do you have a measurable outcome to sort of demonstrate that this is my cost, this is the benefit, and this is the ROI? So if you have that on the paper or after demonstrated using a pilot or something, the business case will sail through. And also, understanding the provider's credentials, right? I mean, have they experience delivering at large scale? We have personally gone to a lot of environments where some organization did it, the experiment failed, and now the organization is sort of, very wary of experimenting with us, right? Has the provider done things at scale? Because IoT in lab is very different from IoT in field deployment. Because India is a very tough environment. It has voltage fluctuations, connectivity failures, a lot of voltage, power failures happening, right? And then, of course, the organization has to be stable with backing of, it needs to be a long-term partner. So So I think, that's pretty much, I wanted to cover. I think if I can just take a moment to, help you understand a little bit about Zenetics. So, we
let's come back. Let's cover some of the.
sure.
Okay. I think someone, if we can put on mute. Okay. Again, we spoke of ROI on the implementation cost. You said about 12 to 14 months. There also tends to be a high expense on recurring expenses on the maintenance of the system itself.
Correct.
This is very true for a VMS where a lot of licensing costs and maintaining costs kick in. What is
Correct.
the status with your with IoT?
Yeah. So first of all, when we measure, IoT costs, I mean, essentially, when you sort of say that the cost of recovery, we actually bundle all the first year costs together. So which is hardware, installation, recurring costs, which will still sort of give you a 12 to 14 month ROI, right? So you break even in 12 to 14 months. After that, typically we have seen that whatever you benefits you get, about 20 to 25% or sometimes about 30%. So 20 to 30% is the recurring cost vis-a-vis benefit. So you still continue to incur about 70% benefit from year 2 to year 5 or year 7, because we have executed 5-year, 7-year contracts with the customers. So when you embark into this journey, you make a 5-year TCO plan, total cost of ownership. This is how much, because these are managed solutions. So these are not like a BMS that somebody deploys and they sort of go away, right? So the managed solution is hardware, deployment, AMC, everything managed solution. And then you look at a TCO and a total benefit. So year 2 to year 5, about 20 to 30% recurring cost. And I think I'll tell you why that recurring cost is important, because then the service provider is also aligned with you to deliver that benefit, which is operational efficiency. We are not here talking about an LED replacement that you really don't need the provider to engage with you. They need to engage with you because it's a dynamic environment, and it has to be done. The journey has to be taken up together.
Right. So, I think another very interesting question. It says, in today's environment, the equipment have some level of AI getting inbuilt as part of the base equipment itself. Correct. So apart from integration, what value adds can be expected from an IoT solution?
Yeah. So absolutely, we also see that, there are air conditioners which are talking to internet. There are different types of equipments which are already talking to internet, and it is some. So I think the value to a customer is that having a platform-centric approach. So what I really mean by that is that you need to have multiple, all your assets. So if you're talking about, let's say you have an AC which is intelligent, but you don't have a lighting system which is intelligent. You don't have an exhaust system which is intelligent. So what will happen is that if AC is already intelligent, then I don't need to put additional hardware to make it intelligent. It can just throw the data maybe directly over an internet, right? Which means the hardware deployment cost goes down in that case, but it is still there in other cases. And the customers don't want too many platforms. So for example, the QSR example I was taking, they had probably 10 different brands and 5 different types of equipment. And you can imagine the permutations, but we got everything onto a common platform.
Right.
So the OEMs will enable such smart equipments, which will make life very easy for IoT providers like us, because nobody wants to deploy hardware.
Nice. Okay, next one, and this is specific to our current environment, is saying that as per new and upcoming government regulations, possibly not yet live in India, but the buildings will be expected to have higher exhaust and higher fresh air intake rates. This will be to kind of prevent the infection rates within the office environment. So, if these regulations go live, then will we still have a benefit of IoT in terms of saving energy, or the air conditioning costs would just go off the roof?
So I think, see, the air conditioning cost will increase as you input more, fresh air into the system. Of course, it's going to be depending upon the climate, right? But largely speaking, India is a tropical country, right? And most of the times of the year it's hot, and therefore you need air conditioning. So I think the air conditioning systems may experience more load. But I think, what IoT will do it is that it will contain that cost by doing things smartly, right? You can actually figure out what temperature you need, what humidity you need, which are regulations already set, right? That, maintain temperatures between 25 to 27, humidity levels from 40 to 70%, fresh air exhaust, fresh air, it needs to be inserted more. So I think, and there can be feedback loops based on it, right? And the systems can be automatically controlled. How do you control TFAs? How you control fresh air fans? All of them can be automated.
Sure. And I think just to add to what you said, I think general experience that I have had in many offices where an individual influencing a technician to switch on or switch off the AHU just because he or she is feeling hot or cold, right? And then you have all these aberrations in the whole energy consumption pattern. Now, if you're able to automate that, link it to specific parameters, and as you said, you could possibly bring out a dashboard which could possibly be displayed across the office spaces, then those aberrations go away, and the inefficiency in the system also should then accordingly go away. Okay, next one. Is there an OpEx model available?
Yes. So, yeah, I mean, there are players in the, so we certainly do. I mean, we, as I said, so we as a company are backed by the Hero Group in India, and they're one of our investors. And we have a line of debt with the bank, which finances these assets. And, we can convert a, CapEx into a 3-year or a 5-year OpEx.
Yeah. And personally, I think from my side, I have preferred the OpEx route, for the reason being that, one, yes, it's a new technology, so everyone wanted to kind of try their hands and not put in too much of capital upfront. And we found it's a dynamic solution. There are lots of permutation combinations that you'll keep coming up with as the industry matures. So I think I found it safer to kind of not sink in upfront all my capex and be left, like we have generally been left hanging with our dead BMS systems in the past. So I think that was one of the reasons that I kind of went with the OpEx model. Okay, and I think another one is, what is the system management cost typically and life of the system? I think life is an interesting part. That is also important.
Yeah. So life is an interesting part. So I think, life, so we have been in operations for about 7 years, right? And 7 years is, I mean, I think we have, these systems have been running for 7 years at some of the customer sites. So I think because I think, what we are sort of doing is we are using industrial grade energy meters, which we don't make, we buy from outside, and they're meant to run, for a longer period of time. The sensors we make are industrial grade, the gateways are industrial grade, and sort of they have easily life, spanning 7, 10, 15 years. But what does happen is the technology changes. Right. And after, 5 years, after you have already sort of, taken a huge benefit out of this technology, because this was anyways a low cost technology and delivered you benefit. After 5, 7 years, customers, and we have already sort of seen this with some of our customers, that upgradation starts happening of technology. As I said, Wi-Fi was the previous wireless. Now it is mesh, right? Where it is several advantages that bring up to it. And of course, it is a customer's thing to sort of whether to upgrade.
In between, there's also talk of something called LoRa, right? LoRa,
yeah.
Network.
Yeah. Correct.
I haven't heard of them after that.
So there are wireless. So there is LoRa, which is again operates like Wi-Fi, but it's long range. So, but again, you have the same concept that all the nodes talk to a central gateway. In mesh, what happens is you have one node talking to other, and there are 3 different technologies. There is Zigbee, there is BLE, and there is Google's Open Thread. So we use Google's Open Thread mesh. If you've heard of Nest thermostats in the US, it was Open Thread was in Nest, and that's why Google acquired it and then open sourced it. So those are the emerging technologies.
So, from a conventional standpoint, you'll be capturing a lot of operating data for the spaces that you manage. How do you respond and support the information security concerns of the organizations?
Yep. So there are 2 ways. One is, of course, there are contractual obligations. So we sign confidentiality, intellectual property protection, all of that, because we are we are a company dealing with enterprises. We are that's our DNA. The second is that there are information security measures that are put in place, and everything is documented. So tomorrow, if CIO asks that, what are the information security measures, how the communication is happening? So every communication is encrypted over either HTTPS or MQTTS technologies. These are all secure channels. The data is secure on cloud with multiple layers of security. So all of that documentation is available. And we have seen many enterprise customers adopt it, which means that they have sort of vetted it.
Sure. Another interesting one, I think people have started thinking for the future. So is the HVAC industry moving from HVAC controls and instrumentation to more of an IT and controls industry? What do you think about this transition?
IT and controls industry. So I think there is a interesting concept emerging, which is IT and OT integrations, right? I mean, I think there are a lot of organizations talking about it, that whatever IT systems or the CIOs were there, they were sort of looking at it as that only servers and software systems, etc. But as the equipments become smarter, that's where these need to be converging. And these systems will see, at the end of it, the equipment technology will continue to evolve. We had these initial, traditional compressors, then we came up with inverter technology, which is why now a lot of buildings actually, instead of looking at very large chiller-based systems, are looking at VRF systems, right? It's a lot more efficient technology, right? So that's one side of the innovation. Then there is a connectivity side of the innovation happening, and that connectivity side of the innovation will actually transform it to become IT-enabled systems. And you will have a common platform. In fact, we are working with one customers where they are getting all the data onto a common platform where the IT and OT sort of converges. So it is happening already.
Nice. Thanks, Rahul. I think, okay, one last question possibly I'll take. We are almost out of time. Do you feel FM will dilute into a IT by way of IoT?
So I don't think so, because at the end of it, FM and administration and so they still require that expertise, right? Now, let's say, imagine I say that there is a low condenser side delta T, right? And the IT guys are not going to make anything out of it, right? So I think you still need that expertise to be able to understand and appreciate, because everything is contextual.
So,
right?
My take, Rahul, and my take on this has been that, as FMs, we tend to have mechanical, electrical engineers, but I think a time is coming where we'll possibly need data analysts and data scientists on our teams. Yep. And our decision making will be based on the data and the analysis that they present for us. There is, I think, what Rahul has covered here is possibly tip of the iceberg still.
Yep.
There is a lot more ability of these very, very flexible solutions to do a lot more for you. It's about how creative you want to get about that. So I think that's where I would leave you to think about it, because from where I stand and for what I have experienced and implemented, I think the opportunities are endless. It's only about your creativity and how much you and your teams are willing to stick your neck out and take those steps. Okay, so I think a great session, Rahul. Any closing words from your side? I think we're all so yeah.
No, I think my take on that is that IoT itself is evolving. As you said, it's the tip of the iceberg, and we are also learning a lot in the process. And I think we are learning a lot with customers' evolving requirements. Nobody talked about, for example, air quality monitoring 3-4 years ago, right? Now it is obviously gaining center stage attention. Nobody was talking about predictive maintenance some time ago. This is getting center stage attention. So I think we are, and this is a journey. So I always tell customers that it's not a box solution. It's a living solution, which IoT is there for. It's a combination of IoT plus ML and AI, and it will continue to sort of evolve. It will keep on becoming smarter and smarter with a lot more data, right? So So I think that's that, and that's pretty much it, from our side. I think if anybody else has any questions, I'm happy to sort of come.
So I think a lot of questions, mostly I've tried to handle. Some I couldn't really get the context, so I'm sorry for that. But thanks, Rahul. Thanks for a very interesting session. And hopefully this has helped our members get more information on a subject which keeps popping up everywhere these days. So thanks a lot for being here and sharing the information. Thank you so much.
Sure. Thank you. My pleasure. Thanks, everyone.
Okay.
Have a
And
lovely
thanks
evening.
to all the people. I think any questions possibly can be taken offline then, right? And thank you all for attending.